Hello, welcome back to another video. It's me, Mr. Skays. All right, let's jump into it. Calculus. All right, so we're looking at the question number 6 from the 2018 exam, a non-calculator question. With that being said, let me close my calculator. We don't want it. Get out of my face. Consider the differential equation dy dx equals 1/3 x times y minus 2 squared. All right, I'll consider it. I mean, that's easy enough. Consider it considered. All right, moving on. A slope field for the given differential equation is shown below. Sketch the solution curve that passes through the point 0, 2, and sketch the solution curve that passes through the point 1, 0. 0, 2, and 1, 0. Okay, 0, 2, oops, 0, 2, and 1, 0. Let's do it. 0, 2, oh, they already have them. I didn't even notice that. Here's 0, 2, and here's 1, 0. 0, 2 is on a flat slope. So this appears to just be a nice horizontal line. All of the slopes are just completely 0 at y equals 2. Okay? So by default, that goes there, right? And then you use, again, if I erase this, right? This is like usually a pretty easy point, right? Just take the slope and let it guide you. This slope is completely flat, so I guess I'm going to stay flat. Well, that slope's flat too, so I guess I'm going to stay flat, 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 flat. All the slopes are flat, so I guess I'm going to stay flat. Okay, well, this one, if you look at this point, all right, I'm going up, but the slopes are starting to get less and less and less and less. So I guess I need to become less and less and less and less. And then this is clearly an asymptote that I need to start flattening out. And I'm going down, and you can see how these are all sort of doing one of these. So I'm going to come down and do one of those and then be like that. Clearly, this thing is symmetrical. So you should draw something like, I mean, I hope it's kind of clear that things are symmetrical the way the slopes are appearing, right? Whatever's happening over here is happening similarly over here. So your drawing ought to be pretty darn symmetrical. And I think I did a decent job here. But let's read the scoring guidelines to get a better idea of what we're supposed to do. Curves must go through the indicated points, follow the given slope lines, and extend to the boundary of the slope field. So you can see here that we continued. They're just hugging those slopes. So I feel like I did a pretty good job. And yeah, I mean, I guess that's that. All right, on to the next question. Let y equal f of x. So this is dy dx. So the integral of this is f of x. That's what they're saying. Just to clarify, if this is dy dx, then the integral we're referring to as f. Okay? Let y equals f of x be the particular solution to the given differential equation with the initial condition f of 1 equals 0. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. Use your equation to approximate f.7. All right, let's focus our attention on the tangent line. So we're trying to draw a line tangent to f. So that means we need to know a point on f and the slope of f. Well, the point on f was given to us, right? They want us to draw a tangent line at x equals 1. Well, x equals 1 is what they just told us, right? At x equals 1, f equals 0. So the point that we are tangent to is 1, 0. All right, cool. Now we need to know the slope. Well, that's going to come from dy dx. The slope is going to come from dy dx. All right, so we're going to use dy dx and evaluate it at t equals 1. So that equals 1/3, or I should say x equals 1, sorry. At x equals 1. So 1/3 times 1 times, and what is y? 0. 0 minus 2 squared. So that's 1/3 times negative 2 squared. So that's 4/3. So the point of tangency is y minus 0 equals 1 times, 4/3 times x minus 1. So y equals 4/3 x minus 4/3. You don't even have to distribute that, but I thought I'd just go ahead and write it in slope-intercept form. You could leave it like this in point-slope form. So they told you the point that they were interested in, right? They just handed it to you, basically. Oops, I didn't mean to circle that. They just handed it to you, essentially. You use the differential equation to solve for the slope. You take that point, you take that slope, and you come up with the equation of the line. So then it says to, quote, write an equation and use your equation to approximate f of 0.7. So that just means you're going to use this function and plug in 0.7. And again, when it comes to this stuff, when it comes to especially the non-calculator, when you don't have a calculator at your side, you're done, right? They were very direct. Use that tangent function to approximate. So if you want to approximate f of 0.7, the little squiggle, the squiggly equal sign means approximate. You're going to use this tangent line to approximate it. You're going to plug 0.7 in for x, and boom, you've approximated it. And that's all you need to do. Looking at the scoring guidelines, that's all they did. You don't need to get negative 0.4. Please don't waste your time with getting negative 0.4. Complete and utter waste of time. Just stop at 4/3 times 0.7. Oh, shoot. No, I did it right. Yeah. Their answer looks a little different because I distributed the 4/3. Sorry. I had a mini panic attack that I did it wrong. I had distributed the 4/3, whereas they didn't. Okay. Cool. All right. Let's look at the last question. Find the particular solution y equals f of x to the given differential equation with the initial condition f of 1. So we were told this one random fact about f, that f of 1 equals 0. But now we want to know what is the equation, right? You remember the line that we just drew? Remember the line that we just drew, the curve that went through 1, 0, literally right here? You know what they're trying to ask us to do? They want us to come up with this equation. They want us to come up with that equation. And we have all the information that we need. Okay? We need to integrate dy dx and use the initial condition of 1, 0. We need to integrate dy dx and use the initial condition of 1, 0. So what is dy dx? I'll write it down here. Dy dx is 1/3 x times y minus 2 squared. So we need to integrate and use the initial condition of 1, 0. So this is when we separate our variables. I'm going to divide by y minus 2 squared and multiply by dx. Whoops, dx. So that way this cancels out and the dx goes over here. So here, I'll do it in 2 steps. I'm going to multiply by dx. So dy equals 1/3 x times y minus 2 squared dx. And then I'm going to divide by y minus 2 squared. And as you can see here, I have the y's entirely on one side, and I have the x's entirely on the other. I'm going to integrate both sides, and it might be better to think of that as let me look at my work to jog my memory. Was I clever about anything? Yeah, so I wrote this as y minus 2 to the negative 2, right? Just to sort of help my brain. This is literally just chilling. So when you do this, this becomes y minus 2 to the negative 1. So remember, when you integrate with power rule, you bump this up by 1 as opposed to going down, and then you divide. So when you divide by negative 1, this becomes negative. Now, I kind of been breaking a little bit of rules here by not doing u substitution, but because this is just a y, the derivative of y is just 1. So like chain rule doesn't actually mess with anything, right? If you know what I'm saying, great. If you don't, I guess it doesn't concern you on this particular problem. And this is going to be bumped up to 2, and we're going to divide by 2. So this is going to become 1/6 x squared plus c. So when I integrated, I bumped this up by 1 and divided. When you divide by negative 1, it becomes negative. I bumped this up by 1 and divided. Dividing by the 2 gets you the 1/6, and that's plus c. Now I'm going to plug in the initial condition of 1, 0 in order to solve for c. So negative 0 minus 2 to the negative 1 equals 1/6 times 1 squared plus c. I'm literally going to run out of room. Holy freaking cow. So this becomes negative 2 raised to the negative 1 is going to be a positive 1/2, right? Equals, this is 1/6 plus c. So 1/2 minus 1/6 equals c. If I get a common denominator here, which is probably wise to make the math a little bit easier down the road, this comes out to 1/3. So 1/3 is c. All right, so if 1/3 is c, I come back up here and I say, all right, this is negative 1 over y minus 2 equals 1/6 x squared plus 1/3. All right. I'm trying to solve for y at this point. In case you forgot what the objective is, it's to integrate and solve for y. Now, the more savvy you are with the algebra here, the better. But what I think is easiest is to combine these two terms. So this is 2/6. So this is x squared plus 2 over 6. And then I'm going to take the reciprocal of both sides. And this is y minus 2 over negative 1 equals 6 over x squared plus 2. I'm going to save myself, well, no, I'll write it down. So I'm going to divide this literally by negative 1. So this is going to become 2 minus y equals 6 over x squared plus 2. So this became a negative y. This became a positive 2. And then finally, to solve for y, here's what I'm going to do. I'm going to subtract this over here, and I'm going to add this to over here. So 2 minus 6 over x squared plus 2 equals y. All right. This video is not that long, so maybe I elaborate on my algebra here. So let's recap. We separated the variables by getting this over here and this over here. So we ended up with this. All right. I integrated using the power rule on both of these. Once we did that, there was a c floating around. You plug in the initial condition in order to solve for c. Now that you know what c is, you plug that back in and you just do whatever algebra needs to be done in order to solve for y. And I think it's worth commenting again, this was a little cheeky, okay? This was a little cheeky, all right? Because if it's not literally as simple as just the power rule, but it is because this is just y. I want to take a moment and look at this and go, okay, what happened? We're saying u equals y minus 2 and du equals 1. So I'm writing this as u to the negative 2 du. All right. When I derive this, I get du. When I derive this, I get 1 dy. So du equals dy. So I replaced this with u, and so you get to use the power rule here. So u to the negative 1 divide by negative 1, so this becomes a negative. And, well, what is u? It's the y minus 2. All right? But if u were something else, like what if this was y squared inside of it, right? Well, look at what would have happened. Y squared minus 2 derives to be 2y dy. You follow what's happening here? So the u substitution is not clean. It's not going to work out because this du is 2y dy. Remember, we somehow have to substitute in du, but where's the 2y, right? We don't have it, right? Hopefully the u substitution is coming back to you. If not, you should take some time and do some u sub problems. If you're looking at me going, I don't know what you're saying, Mr. Skis, maybe you should go back and do some u sub problems. But yeah, because it's just y, it's a little cheeky, and it works out nicely. All right. If you're still with me, great, fantastic. Let's look at the scoring guidelines on this final bit. It wants you to, 1, separate the variables. That gets you a point. It wants you to 2 points to get the antiderivative. So this antiderivative of negative 1 over y minus 2 gets you a point. And this antiderivative of 1/6 x squared plus c gets you another point. Awesome. So being able to separate variables and integrate is getting you 3 points out of 5. Incredible. Finding that constant of integration, 1/3, gets you the 4th point. And finally, doing all the algebra and getting y gets you your final. All right. Thank you for your time. Under 20 minutes here. Hope you appreciated this one. I will catch you later, and enjoy the rest of your day, evening, morning, whenever you are, wherever you are. I'll catch you later.